Hi students, I am Praveen Sebastian Paul. In this lecture, we are discussing the cyclomatic complexity. The cyclomatic complexity of a code section is the quantitative measure of the number of linearly independent paths in it. It is a software testing metric used to indicate the complexity of a program. It is computed using the control flow graph of a program. The node in the graph indicate the smallest group of commands of a program and a directed edge in it connected to two nodes, that is, if second command might immediately follow the first command. For example, if a source code contains no control flow statement, then its cyclomatic complexity will be 1 and the source code contains a single path in it. Similarly, if the source code contains one of the conditions, then the cyclomatic complexity will be 2 because there will be two paths, one for true and one for false. Mathematically, for a structured program, the directed graph inside control flow is edge joining two basic blocks of the program, as a control may pass from first to the second. So the cyclomatic complexity M is defined as M is equal to E minus N plus 2P, where E is the number of edges in the control flow graph, N is the number of nodes in the control flow graph, and P is the number of connected components. The different steps that should be followed in calculating the cyclomatic complexity and test case designs are: construction of graph with node and edges for the code, identification of the independent path, cyclomatic complexity calculation, and design of test cases. If we are considering the following code section, that is, the following code is A is equal to 10, and if B is greater than C, then A is equal to B, else A is equal to C, and if, and print A, print B, and print C. The control flow of this particular code is given like this, that is, we are starting, then we are initializing A is equal to 10, and then we are moving to a particular branching statement, that is, the branch is B greater than C. If that particular condition is satisfied, then, that is, if B is greater than C, then B is assigned to the A. If B is less than C, then C is assigned to A, and finally we are printing A, B, and C and exiting from that particular code section. Then the cyclomatic complexity calculated for the above code will be from the control flow graph. The graph shows 7 different shapes or nodes and 7 different lines or edges. Hence, the cyclomatic complexity is 7 minus 7 plus 2, that is, the result will be 2. And the different uses of cyclomatic complexity is: this cyclomatic complexity determines the independent path executions and thus proven to be very helpful for the developer and the testers. It can make sure that every path have been tested at least once, thus help to focus more on uncovered path, and code coverage can be improved, and the risk associated with the program can be evaluated, and finally these metrics being used earlier in the program helps in reducing the risks. So my dear students, all these mechanisms are covering under the white box testing techniques. If we are considering this white box testing at a glance, the most important part in the white box testing methods is the code coverage analysis, which empowers the software engineering team to find the area in a code which is unexecuted by a given set of test case, thereby helping in improving a software application quality. There are different techniques which can be used to perform the code coverage and analysis, and some of these techniques are statement coverage, and this technique is used to test every possible statement at least once. And second one is decision coverage, which includes the testing each and every possible decision conditions and other condition loops at least once. The third one is a conditional coverage, which makes one-time code execution mandatory when all conditions are tested. And fourth one is a decision or conditional coverage, and this is a mixed technique which implemented to test all the decisions or conditional coverage at least once while the code is executed. And finally, the multiple conditional coverage technique. In this type of white box testing technique, each entry point of the system has been executed at least one time. And there arises a question, what is verified in the white box testing? The answer is simple: the security holes, broken or incomplete path, and the conditional loops in the code are tested, and the flow of structure mentioned in a specification document is verified, expected outputs are verified, line by line or section by section in the code is thoroughly checked, and finally each statement, object and function is tested individually in the white box testing mechanism. The different advantages of this white box testing are the code optimization by revealing the hidden errors are the major advantage, the transparency of the internal coding structure, which is helpful in deriving the type of input data need to be tested and application effectively. It covers all possible paths of a code, thereby empowering a software engineering team to conduct thorough application tests, and it enables the programmer to introspect because the developer can carefully describe any new implementation, and the test cases can be easily automated, which gives the engineering based rule to stop testing an particular application. The major disadvantages of white box testing are as follows: a complex and expensive procedure which requires seasoned professional expertise in programming and understanding of the internal structure of a code is a major disadvantage or drawback of the white box testing, and the updated test script required when the implementation is changing too often. Exhaustive testing becomes even more complex using the white box testing method if the application of large size. Some condition might be untested as it is not realistic to test every single one necessary to create a full range of input to the test each path, and condition make the white box testing method more time consuming. And finally, defects in the code may not be detected or may be introduced considering the ground rule of analyzing each line by line or path by path in this particular testing method. The white box testing is useful for component integration and system testing and enables the identification of errors in the code syntax, logics, data flows, and conditions. So dear students, by this lecture we had completed the white box testing scenarios, that is, we had completed the module number 2. So dear students, kindly go through this assignment question. The first question is, write about the cyclomatic complexity, and the second question is, brief the white box testing technique. So dear students, see you soon. Until then, goodbye, thank you, and all the best.